Now we're going to add two nodes into our chain to change the color of the particles, which actually we're going to be using as sort of a data feed to be able to recolor them later down the line, as well as we're going to add some wind into the system to be able to create a more pretty particle result. All right, so out of the particle source node, I'm going to right click here. I'm going to type pop color. We're going to lay that in here. Okay, we have a pop color node. And this node is really useful because it allows us to control the color and the alpha of these particles. And what I often do is basically just set a ramp on these particles that has the color based on the age, and I can use that data once we've pulled the particles back into SOPLAN to recolor them. Because often I'll bake out a particle simulation, but I want to maybe be able to tweak the colors later. I don't want to have to bake all that information in now. So what I'm going to do here is under the color tab, under the color type, I'm going to change this to ramp. And actually all these defaults are going to work for us. We have a ramp going from black to white, and that's driven by normalized age. This @nAge variable is the normalized age from 0 to 1 of that particle, and now it'll ramp that from black to white. So now if I play this back, let me move this over so we can see it a little bit better. You can see that the particles are going to start off black and then they're going to go to white as they go over time. So it's basically like a lookup table that we can use down the line to know how long that particle has been alive. Okay. So now we're going to add a node that's going to help shape our movement, because we still have these flying off wildly, and often we want to introduce a little bit of noise and wind into our particle system to give us some organic motion. So let me rewind that. I'm going to pull these down, and I'm going to lay down a pop wind node. Okay, so this is pretty powerful. Use this for a lot of different things. And what we're going to do here is we're just going to change some settings. First off, we are going to change the amplitude to 2, and we're going to change the swirl size to 2, so it's just a bigger noise swirl. And we're going to change the roughness down to 0.25. Okay, so let me just play that back. First off the bat, you can see that now our particles aren't sort of just flying off because there's a little bit more wind resistance in here. But the one thing is that there's sort of just almost too much noise on everything, and we lose that directionality we had of the particles emitting. What I want to do is create something where there's not a lot of noise on them in the beginning, and over time the noise gets introduced as if they were, had more strength in the beginning, and then as they were emitted and became, lighter, they kind of drifted off in the air. So what we're going to do is we're going to do a really simple Vexpression on these. So I'm going to turn on the Vexpression tab here. And what we're going to do, if we scroll over amplitude, we can see that that parameter is simply called amp. So what we're going to do is we're just going to modify that. So I'm going to do amp multiply equals fit01 @nAge 0.2 and 1. So what this is going to do, it's going to say take the normalized age, which is 0 to 1, and fit that between 0.2 and 0.1, and multiply the amplitude of the noise by that. So we're basically saying give us a little bit, just 0.2 of the noise as the particle is birthed, and then over its lifetime, scale that up to 1. So simple little expressions like this they use all over the place just to be able to have things modulate over time. So now you can see with our particle simulation, as the particles move originally, we still get that kind of nice streaky beginning, but then they kind of float off and drift off after they've been on screen for a little while. So that's a great way to be able to shape particles with just some really simple expressions. And obviously, we're not using that many particles right now, and it's super fast, but even if we scale this up to a lot more particles, this system is incredibly efficient, and it's really great to be able to work with large numbers of particles really quickly and efficiently like this. Okay, so for this chapter, we're looking at rendering these particles as sprites. So next we're going to look at the pop sprite node to see how we can start attaching a sprite shader to these particles.